also some questions which are different in the set 3. Now we will start that. Question number 9. Evaluate 0 to pi by 2 ex sin x minus cos of x dx. 0 to pi by 2 ex sin x plus minus of cos of x. This is fx, f dash x, f of x, f dash x plus f of x. Derivative of cos is minus sine, so derivative of minus cos is sine. What is the formula for this? Integral of ex fx plus f dash x, that is equals to ex f of x. So ex f of x is minus cos of x. Limit goes from 0 to pi by 2. Put the limits. E pi by 2 cos pi by 2 minus minus plus e0 cos 0. Cos 90 has value 0. Cos 0 has value 1. Write a unit vector in the direction of sum of vectors. A vector, question number 10. A vector is equals to 2i plus 2j minus 5k, and B vector is equals to 2i plus j minus 7k. We have to write the unit vectors with sum of these vectors. So A plus B vector, 2 plus 2, 2 plus 1, minus 5, minus 5. Now the required unit vector is equals to sum of these vectors upon magnitude of sum of these vectors. A plus B vector upon magnitude of this. A plus B is 4i plus 3j minus 10k. Magnitude 4 square plus 3 square minus 10 square. 4i plus 3j minus 10k. 4 square 16 plus 9 25 plus 100 125. 4i plus 3j minus 10k. Here we have 7k. So 7 plus 5 is 12. 12 square is 144. And 144 plus 25 169, that is 13. 4i plus 3j minus 12k upon 13. Now the next one is question number 19. Using properties of determinant, prove the following: x square plus 1, xy, xz, xy, y square plus 1, yz, xz, yz, z square plus 1, that is equals to 1 plus x square plus y square plus z square. Using properties we have to prove this. First take x, y and z common from R1, R2 and R3. R1, R2 में से हमने y कॉमन लिया and from R3 we take z common. Now multiply column 1. If we multiply, then we will have to divide also. Column 1 by x, column 2 by y, and column 3 by z. 1 plus x square plus y square plus z square, 1 plus x square plus y square plus z square, y square z square, y square plus 1 z square, y square z square plus 1. So it is common. Take 1 plus x square plus y square plus z square common from column 1. So we are left with this. Now in the next step, operate R1 as R1 minus R2 and R2 as R2 minus R3. 1 plus x square plus y square plus z square, y square minus y square, z square minus z square, 1 y square z square plus 1. Now expand this determinant along the first column. First two terms are 0, minus 1, 1, 0, minus 1. So 1 plus x square plus y square plus z square, minus 1 into minus 1 and 1 minus 0. So we get the result as 1 plus x square plus y square plus z square. Now the next one is question number 20. Differentiate tan inverse square root of 1 plus x square minus 1 upon x with respect to sine inverse 2x upon 1 plus x square. Let this as y and this as z. Put x is equals to tan theta 1 plus tan square theta with plus 1. We have the formula for 1 plus tan square is sec square. So we are putting here tan. 1 plus tan square is sec square. Integral square root of sec square is sec upon tan theta. Now put the value. Sec is 1 upon cos and tan is sine upon cos. So 1 minus cos theta upon sine theta. Now use the formula. Cos 2 theta is 1 minus 2 sine square theta. 2 sine square theta is 1 minus cos 2 theta. If angle is half here, then it becomes 2 sine square theta by 2. So instead of this, we will write tan inverse 2 sine square theta by 2. Sine 2 theta is 2 sine theta cos theta. So here it becomes 2 sine theta by 2 cos theta by 2. Now sine upon cos is tan. Tan inverse tan theta by 2. So y is theta by 2. Now in the z, put x is equals to tan. Sine inverse 2 tan theta upon 1 plus tan square theta. We have the formula for sine 2 theta, that is 2 tan theta upon 1 plus tan square theta. So sine inverse sine 2 theta. So z is 2 theta. Differentiate it with respect to theta, we get 2. Differentiate y with respect to theta, we get 1 by 2. Now we want the differentiation of y with respect to z. So we can write it as dy upon d theta into d theta upon dz. dy upon d theta is value 1 by 2. dz upon d theta, so we get 1 by 4. one is find a particular solution of the differential equation dy upon dx is equals to x into 2 log of x plus 1 upon sin y plus y into cos y, given that y is equals to pi by 2 when x is equals to 1. Now separate the terms here. Sin y plus y cos y dy. Integrate both sides. X into 2 log of x plus 1. In this interval, algebraic as first, trigonometric as second. Algebraic as first, logarithmic as first, and algebraic as second. Elate. Inverse L for logarithmic, therefore logarithmic as first function and x as second. Integral of sine, first function, integral of cos, minus integral of derivative of first, integral of second, first function, integral of second, derivative of first, derivative of log of x is 1 upon x, 1 is 0, integral of x is x square by 2. So minus cos of y, integral of cos is sine, integral of cos is sine, derivative of y is 1, integral of x is x square by 2, integral of x is x square by 2 plus constant of integration c. Now we have to put the values. Minus cos y plus y sin y. Integral of sine is minus cos. So minus minus plus x square by 2. 2 log of x plus 1 minus 1. So it will get cancelled. So y sin y is equals to x square by 2. 2 log of x plus c. 2 will also get cancelled. Now put the value of y is pi by 2, sin pi by 2, x is 1, log of 1 plus c. Sin 90 has value 1 and log of 1 has value 0. Pi by 2, log of 1 is 0. So put the value of c. Y sin y is equals to x square log of x plus pi by 2. Next question is question number 22. Show that the lines r vector is equals to I plus j minus k plus lambda 3i minus j and r vector is 4i minus k plus mu 2i plus 3k intersect. Also find their point of intersection. We can write it as 1 plus 3 lambda I cap plus 1 minus lambda j cap minus k cap, 4 plus 2 mu I cap plus 0 j plus minus 1 plus 3 mu k cap. Now Let this line as 1 and this line as 2. P be the point 1 plus 3 lambda, 1 minus lambda minus 1. We point on line 1 and Q as 4 plus 2 mu 0, 3 mu minus 1. We point on line 2. Now these two lines intersect. It means these points must coincide. If these points coincide, then equate 1 plus 3 lambda is 4 plus 2 mu. 1 minus lambda is 0. So we get the value of lambda as 1. 3 plus 1, 4. So we get the value of mu as 0 and lambda as 1. Putting this value of lambda and mu in equation 1, let this as 3. Put this value of lambda and mu in 3. 1 plus 3, 4 plus 0. So this is true. Therefore, these two lines intersects. Therefore, these two lines intersect. Now we want to find the point of intersection. So point of intersection is, put the value of lambda here, 1, 1 minus 1 and this is minus 1. 4, 0, minus 1. अगर हम Q में put करेंगे तब भी हमें same points मिलेंगे. Mu is 0. So this is the point of intersection of these two lines. Now the next question, which is different, is question number 28. Evaluate integral 0 to pi by 2 x sin x cos x upon x sin x cos x upon sin 4x plus cos 4x dx. Let this integral as I. Now use the property 0 to a f of x dx, 0 to a f of a minus x dx. Now put the value 0 to pi by 2 minus x, sin pi by 2 minus x, cos pi by 2 minus x dx upon sin pi by 2 minus x power 4 plus cos pi by 2 minus x power 4. We know that sin 90 minus theta is cos and cos 90 minus theta is sin. So we get cos x, sin x, cos of 4x plus sin of 4x. Now let this equation as 2 and this as 1. Now add 1 and 2. 2i is equals to 0 to pi by 2. Sin x cos x is common in the numerator. X plus pi by 2 minus x dx. So we get I as pi by 4, 0 to pi by 2, sin x cos of x, sin 4x plus cos 4x. Now numerator and denominator में divided by cos 4 of x, sin x cos x upon sin 4x upon cos 4x plus 1 dx. So pi by 4, sin upon cos is 10, cos square, 1 upon cos square is sec square x, tan 4x plus 1 dx. Now in the next step, let z is equals to tan square x, then dz is 2 tan x, derivative of tan is sec square x dx. Now put this value, pi by 4 dz upon 2 z square plus 1. The limit will also change. If 0 to pi by 2 was the limit, if x is 0, z is tan square 0. Tan 0 is 0. So when x is 0, then y is also 0. When x is pi by 2, then z is tan square pi by 2. Tan 90 is not defined. So limit goes from 0 to infinity. Now what is the formula for 1 upon x square plus a square? 1 upon a tan inverse x upon a. Put the limits now, pi by 4, tan inverse infinity minus tan inverse 0. Tan inverse infinity, that is value pi by 2. Tan 0 is 0, so we get the result as pi square by 8. Do not forget to change the limits. Is also here, so pi by 8. 8 into 2, 16. Pi square by 16. Now the next one is question number 29. Of all the closed right circular cylinder cans of volume 128 pi centimeter cube, find the dimensions of the can which has minimum surface area. Let radius of cylinder is x, height of cylinder as y, height of cylinder as y. Now what is the volume of cylinder? That is pi r square h, pi r square h, and volume is given 128 pi. Pi will get cancelled. From here y is 128 upon x square. Now we have to ask that which has minimum surface area. Surface area of the cylinder is 2 pi rh plus 2 pi r square. Radius is x, height is y. So surface area is, take 2 pi x common, y plus x. Put the value of y here, 128 upon x square plus x. Take the LCM. 2 pi x 128 plus x cube. So 2 pi 128 upon x plus x square. Now take the derivative, ds upon dx. 2 pi is constant. Derivative of 1 upon x is minus 1 upon x square. X square is 2x. 256 pi upon x square plus 4 pi x. Now for the points, put that first derivative is equals to 0. ds upon dx is equals to 0. Minus 256 pi upon x square minus 4 pi x. Pi will get cancelled, negative sign cancel. 64 is equals to x cube. 64 is 4 cube. So we get the value of x as 4. So x is equals to 4 centimeter. Now find the second derivative, d square s upon dx square minus 256 pi, derivative of x power minus 2, minus 2x minus 3, derivative of x is 1. So 4 pi minus minus plus 2 into 256 pi upon x cube. So this derivative has positive value because all these terms are positive. If second derivative is positive, then it is the point of minima. Therefore, the surface area is minimum. Therefore, surface area is minimum. Now we have to find all the dimensions. So y, we want to find y is 128 upon x square. 4 square is 16. So we get the value of y as 8 centimeter. Therefore, the surface area is minimum. Radius of cylinder is 4 centimeter and height of cylinder is 8 centimeter. Note it down.